4.2, graphing linear equations into variables. So for this section, and also for chapter 4, it's a good idea to practice graphing. And if you have graph paper, it'll just make it a little neater and easier for you to graph. So graph paper is really good in this section if you have some. So in this section, I have a few definitions. The first thing that we want to look at is definition for a linear equation, and it's just an equation that represents a straight line. And we can write our linear equation in two ways. So the first way is called standard form. Ax plus by equals to c, and we just want to make sure that a and b are not both 0. And the next equation, or linear equation, we can also write our linear equation in slope-intercept form. Y equals mx plus b. I'm pretty sure this is the one that a lot of you might remember, where m is called our slope and b is your y-intercept. So what is a y-intercept? A y-intercept, next definition, is an ordered pair of the form, it says 0, y. So anytime I say y-intercept, x is always 0 and y can be any value. And when we say x-intercept, it's an ordered pair where y is always 0 and x could be any number. So let me show you two graphs where we have to determine the x and y intercept. So to have a better understanding, let's take a look at the next example, or the next two examples. So what we want to do here is we would like to find the x and y intercepts, and we want to write our answer as an ordered pair. I will ask you to write your answers as ordered pairs on your test. If you're given a graph, for example, like A and B, all we need to do is look to see where does our line intersect the x-axis and read the point. So the ordered pair right here is 2, 0. That's our x-intercept, so we can write our answer. Our x-intercept is of the form 2, 0. And our y-intercept is the point where the graph crosses the y-axis. Well, it crosses the y-axis right here, and we just read off the point from the graph. And so x is 0 and y is -3. Okay, so we have our x-intercept, y-intercept. Let's take a look at B. Again, x-intercept is where your graph crosses the x-axis. Y-intercept is where your graph crosses the y-axis. So you just basically read your answer from the graph. So for your x-intercept right here, as an ordered pair, we say 4, 0. Remember, x-intercept y is 0 all the time. And for our y-intercept, right here, x is 0 and y is 2. So we have our answers. So basically, if you're given a graph, you just look to see where your graph crosses the x-axis and the y-axis, you read off the point, and you have your two answers. If you are given just an equation to figure out the x and y intercepts, let me show you how to do that. Let's look at example C. To calculate the x-intercept, remember for your x-intercept, y is 0, so we substitute 0 for y. And we solve for x. 7 times 0 is 0, and so we really have 3x equal to 21. To solve for x, divide by 3. X is equal to 7. We want to write our answer as an ordered pair. So the ordered pair is going to be 7, 0. So that's one solution. And now to find our y-intercept, you have to substitute 0 for x. Solve for y. 3 times 0 is 0. We are left with 7y equal to 21. How do you solve for y? Divide by 7 both sides. My answer is y equal to 3. Now you need to write your answer as an ordered pair. So in this case, it's 0, 3. If you have the x-intercept and the y-intercept, you can easily draw the graph. All you do is just graph these 2 points and connect them with your straight line, and that'll give you the graph. So this would be one way to graph. Let's find the x and y-intercept for example D. So we'll start with the x-intercept. For x-intercept, substitute 0 for y. It's always the opposite variable you substitute 0 for, which gives us 2/3 x equal to 4. Remember, to isolate x, you have to multiply by the reciprocal, which would be 3/2. Same sign, just reciprocal. 3/2. You do it to both sides. You can write 4/1. You multiply fractions, numerator times numerator, denominator times denominator. Right here, we can reduce, and we're just left with x. And multiply across, which gives me 12/2. And of course, when you reduce, you get 6. So now we want to write our answer as an ordered pair. The ordered pair in this case is going to be 6, 0. Last, find the y-intercept. Okay, y-intercept, substitute 0 for x. So we know this fraction goes away. All right, so we have -3y equal to 4. Divide by -3, we get y equals -4/3. You want to make sure you write your answer as an ordered pair, 0, -4/3. And then we have our final answer. So the question right now is, if you were asked to graph, you can easily graph these 2 points. I can easily graph 6, 0, but how do you graph this fraction? So if you have a fraction, what you want to do is you just divide. And so when we divide, we'll figure out that -4/3 is the decimal -1.3 with a bar, so it's a repeating decimal. So -1.3, basically what you do is just estimate the location on your graph. On your test, I will give you regular whole numbers. So you'll just have integers, positive, negative. You won't have any fractions to graph for your test. But if you have to graph them for your for the problems in the book, you just estimate. So -1.3 repeating is between -1 and -2. So we just estimate the location on our graph. So for example, if I'm looking at this graph, this is -1, it's -2. And so it would be right here. So you just estimate that location. So you could estimate it and just put a dot right there. So that's a good way to estimate.